Hello, everyone. This is the Transformative Vertical Flight Public Service Group. This is meeting 107. Today is Thursday, June 18th, 2026. Today we have a superstar speaker, Kristina Menton. She is the Chief of Flight at Pivotal. Uh, we're so happy to be able to get her to speak with us. I think many of you know various activity from Pivotal, and I don't think we can get a better speaker than Kristina to really highlight the progress made, the different applications, including the public service operations they've been putting a lot of effort in. Um, Brief introduction for our speaker. Kristina Menton is the head of flight at Pivotal, where she leads flight operations, flight tests, uh, pilot training, safety, and customer flight programs for the company's electric vertical takeoff and landing eVTOL aircraft. An engineer, fixed-wing pilot, and eVTOL test pilot, she has spent nearly a decade before helping develop, test, and operationalize one of the world's first commercially available personal eVTOL aircraft. I think many of us familiar with that airplane. I don't know how many videos have been watching that thing take off and land. It just never ceases to amaze me. Prior to Pivotal, Kristina held engineering role at Pratt and Whitney, Canada, and Alstom Power, and studied at the University of Toronto and MIT. Before I hand the floor to Kristina, I'm going to go through our routine uh, reminder of some of the forthcoming meetings. Encourage all members to attend whenever possible. The important one that's coming up is the 20th Electric Aircraft Symposium, taking place July 18th to 19th in 2026. This is basically co-located at the same place in Oshkosh. It's a 2 days, just a day before, the couple of days before the EAA Oshkosh, I can see on the right. For anyone who hasn't been to Oshkosh, strongly encourage you to go there, experience the magnificent experience of aviation. I took a look at the last year's event. The there were 100,000 I'm sorry, 10,000 airplanes actually participated, and a quarter of them were actually registered as exhibit airplane. So you never know what you're going to find, what you're going to see. There's a lot to see, and there's increased participation in the eVTOL related field. So I encourage everybody to participate. Also, this forthcoming in September, this commercial UAV Expo. It's going to take place in Vegas, as well as the same time, roughly same time in September, is a European Rotorcraft Forum. Both are a well-organized, well-attended events, and everybody can learn a lot from engaging in those events. So those are some of the near-term events. Encourage everybody to participate. And with that, I'm giving the floor to Kristina. Kristina, the floor is yours. I'm going to unshare so you can take over. Go ahead.
Thank you very much, Johnny. It's an honor to be here. I'm just waiting for the presentation to load, but it's an honor to be here talking to the transformative vertical flight. and specifically the Public Services Group, because that's something that Pivotal has been really focused on in 2026 so far. And I'm very excited to share our updates with this group. I am at one of our test sites today. We're actually training a customer how to fly the aircraft and looking at some experimental R&D. So if you hear any noise in the background, that's just an aircraft taking off or landing from the strip that we have right here. So thank you for having me. I'm going to go over a little bit about Pivotal, the company. I'm sure that many of the people on this call I actually recognize or are very familiar with our company, but some may not be. So I'll talk about our company, our mission, and our history as to how we got to where we are today. Then talk a little bit more about response and the anatomy of a flight. What is it like for an EMS paramedic to fly a Helix aircraft? So we are a 13-year-old startup company. We've got about 115 employees building this novel, elegant, fault-tolerant, and scalable tilt aircraft aero architecture design. So the aircraft and the company have stayed very streamlined. We've been very focused on Part 103 aircraft that are legal to fly in the US, as long as they meet the weight requirement, the speed requirement, and the operational requirements around Part 103. So that means that the aircraft is very light. It's a tilt aircraft and not a tilt rotor. And 13 years of experimental R&D are behind us. So we really understand this vehicle and this product and this market, and we're very excited about what's coming next in this area. So the aircraft is design. It's software controlled. So it's a fly-by-wire system with electric propulsion systems. There are 8 propulsion systems in the aircraft, as well as 8 avionic systems. We rapid prototype at our factory and use simplified flight controls. That's a picture of our company. There's a lot of smiling faces in there. We're very proud to be based in California and Palo Alto right now and branching out within the US as well. We've got a team that's mostly in person in Palo Alto, but we do have some people who are remote across the country or who are working with us in other countries as well. And right there is our facility in Palo Alto. Dan Abir, if you could mute, that would be excellent. So we've got 3 generations of BlackFly aircraft that have led to the Helix aircraft that is now our production aircraft. We're the first in eVTOL to sell and ship to customers, which we did for the first time in 2023. 14 aircraft were delivered between 2023 and 2024. We've also got greater than 10,000 flights, greater than 50,000 miles flown, greater than 2,500 crewed flights, including owners, training flights, testing flights, and demonstrations that we've done around the US and Canada. Greater than 45 aircraft have been built with greater than 59 pilots trained and certified to fly. And we became the most flown civilian-powered lift aircraft globally in 2025. The pilots who are flying with us, they're anything from test pilots and seasoned aviators to first-time pilots, people who have no sense of extreme sports, do not drive motorcycles. Some of them are accountants, are teachers. What the beauty of our aircraft, our training system, and our architecture is just how intuitive it is to be able to fly. The simulators that we use for our flight training are incredibly similar to what the aircraft actually feels like in flight. So you build a lot of confidence over the training program before your very first flight, which is a solo. We were the first aircraft to enter production on our roadmap is Helix. And the company history, so this is just that 13 years that I was just discussing. 2021 is when Marcus Lang, our founder, did the very first flight of the proof of concept vehicle in Ontario, Canada. And that really spearheaded that we have the technology available right now in 2011 to build the motors, batteries, and flight controllers to have a fly-by-wire, very light, very intuitive, and redundant system. That led to investment in the company and a move down to Palo Alto, California in 2014, where we built the Generation 1 aircraft. and then moved on to generation 2, which was the first aircraft to fly. I was one of the lucky three to be one of the first three to fly that aircraft back in 2016. It was a in 2018. It was first flown as a UAV in 2016 and then brought to human operations in 2018. And we were the first people to be doing that in the US. It was incredibly exciting. And at the time, there was a huge amount of training. We needed to figure out how to make the transition between hover and cruise really intuitive. So there was hours of training, there was hours of safety review board meetings, figuring out how do you create an intuitive system that is using the sensor data from GPSs, from pitot tube sensors, and radar systems with someone who doesn't have a pilot's license and needs to be able to command and control this aircraft like a pilot. Then in October 2019, we had 30,000 miles flown in the BlackFly aircraft. We did that uptime and endurance to really understand the system. We then launched our very first air show human flight at Oshkosh, EAA Air Venture, in front of over 600,000 people. Then in July of 2022, more human flight operations at Oshkosh, this time entering cruise and really showing what the aircraft was capable of. Then in 23, our first customer delivery of a BlackFly aircraft. And then later in 2023, we introduced the Helix production aircraft. That aircraft is what we're building and testing and designing today. So we've received a ton of recognition, which is fantastic. Many people have been able to come in, learn how to fly the aircraft in 1 to 3 days as a reporter or a member of the media to really get that firsthand experience. Because when you watch the aircraft fly, when you watch our videos, the experience as an observer is very different from the experience in the cockpit. So having these reporters be able to experience what it's really like to go through our training program, what it really feels like to sit in the cockpit for that very first flight, and what it feels like to do a check ride and actually earn your qualification to be able to fly the aircraft independently on your own is something that was really important to us and has gained us some great recognition. Then a little bit about how the aircraft flies. So the aircraft is an eVTOL aircraft. It's electrical and takes off vertically. So the first 10 feet of takeoff is autonomous every time. The pilot can take over, but the sensors take it off the ground in a nice swooping motion up into the vertical orientation and then put it in a position hold where now the operator or pilot has control to be able to pitch forward and fly the aircraft. Prior to that first takeoff, it does built-in checks of all of the critical systems of the aircraft to ensure that it is in good working order, and then it continues to do that throughout flight. Then at an altitude of about 50 feet, we encourage you to move forward, start translating forward, and then enter into cruise. When you're in cruise mode, it no longer does position hold, but it does cruise speed hold. So based off of the pitch of the aircraft, it'll hold your altitude and hold your speed to be able to maneuver. It's actually quite comfortable in cruise. That's where you can release the stress. You can fly at 30, 40, 50 miles an hour and really take in your environment with the excellent view you get out of the cockpit. This aircraft, Helix and BlackFly, can both be flown crewed or uncrewed. When they fly crewed, they're as a Part 103 aircraft, and when they're uncrewed, they fly as experimental in Part 91. So as many of you know, we have 3 different focus areas within our market at Pivotal. The first is the personal aircraft, which is consumer, private, within Part 103 for recreation, transportation, private AAM aircraft. The second is defense missions that we use that optionally crewed, contested logistics, or convert insertion and extraction. And the third is public service, and we're renaming that to response, public and private response. The production personal aircraft, so Helix aircraft, we have orders of the Helix aircraft. That's the generation 4. It's a whole aircraft revision of the BlackFly. It looks very similar from the outside, but the inside is quite different. Was informed by the U.S. Air Force airworthiness evaluation, enhanced payload, range, endurance, avionics, cockpit, and composite structures on the airframe. It's got new power distribution architecture, enhanced energy storage and propulsion, It exceeds DO 160G, which if you're familiar with EMC and EMI testing, that has to do with its immunity and its susceptibility to electromagnetic interference. And the basis of Pivotal Tech platform. It's a Part 103, single passenger and amphibious. So very similar to the BlackFly aircraft in its actual operating envelope. And it's currently in flight testing and system integration and test, with first customer shipments later this year. Then we have the DoD aircraft, which isn't bound by the FAA requirements in the US, although we still have the Class 1 aircraft, which is very similar to the Helix aircraft. The Class 2 aircraft would be a larger aircraft, so distributed battery architecture similar to Helix, but additional propulsion systems, additional batteries, potentially additional passengers, and the ability to fly crewed or uncrewed. And then the Class 3 aircraft, so again, much larger, larger propellers, double redundant power bus, consistent with the Helix aircraft. It's triple modular redundant communication power bus, but it could have 2 passengers. It could be used for cargo and carry much larger payloads. And then finally, we have the Emergency Medical Services pilot project. So that third area of the market is the public safety and the response. And that's what I think this group is most interested in. So in 2025, we launched a video where we were showing a demonstration of what it could look like for a Helix aircraft to operate within response, showing a paramedic entering into a vehicle and being able to follow for a response. So this is a real world EMS capability. This is not something that we're hyperbolicing into the future. We've actually partnered with Hyde County in North Carolina and Code Blue Resources, where we have 2 aircraft deployed and registered today. So to operate within a EMS response capability, that's outside of recreation. So it's no longer within Part 103. So what the aircraft has to be registered as a Part 91 aircraft, have N numbers on it and fly under a PAO. The aircraft would augment but not replace ambulance deployment. So if you think about an environment like Hyde County, where it is rural, there's quite a few lakes, rivers, and bridges, and the roads are not well connecting the community. There's actually an extremely long response time that's standard in that area. So having an aircraft that's able to be deployed to bring a paramedic somewhere very quickly is extremely advantageous for the community. We've trained 4 paramedics so far, with the 5th paramedic arriving at Pivotal on Monday for training. We've categorized landing areas around the county that are able to be accessed by the aircraft. Thanks to the VTOL capabilities, most of the county is actually accessible for the aircraft to take off and land. We've done hundreds of rehearsed missions in that area. And we have set up the first eVTOL public aircraft operation. So the public aircraft operation is operated by Hyde County. So the aircraft are under the operational control of Hyde County, but we're largely supporting them to be able to ensure that the appropriate level of rigor is given to the pilots as well as the aviation community to be able to flight plan, deploy paramedics, and categorize landing locations safely. We're actually live in 911 emergency response right now, where a paramedic could get a call and could be deployed in an aircraft, a Pivotal aircraft, to a response. And this is a video of what it looks like.
911. What's your
So what you can see in that video was, and that was from our demonstration flight. But effectively, is we have these two aircraft that are N number registered that are being maintained throughout the day, so that they can be rapidly deployed to any EMS calls that are within the area. The EMS team has been trained to be able to survey the meteorological area. To ensure that the winds are not above any of the operating limitations. If it's a tailwind, you'll get there faster. It's a headwind, you'll get there a little bit slower. And depending on how far you fly, what the return plan is going to be. The aircraft can charge from 120 volt overnight or a 240 volt in about 40 minutes. So figuring out, will we charge and then fly home? Will we actually do a return mission home? Or will we disassemble the aircraft and drive it to a different location? Because the aircraft takes about 30 minutes to disassemble. So there's a huge amount of capability there, and we're quite excited to be the very first eVTOL aircraft to be used that we know of in the world as an active part of public response. Next, I want to talk a little bit about what that looks like for the actual responders, for the first responders, from their mission planning to flight planning, the aircraft assembly and pre-flight checks, finally the flight, and then that post-flight data, which is where they can analyze their flight and performance. So the mission within public safety and response is obviously to be able to bring a paramedic with specialized skills or a bag that has special equipment to a site as soon as possible. So when that phone call comes in or when that dispatcher sends their message, they are sharing with the pilot what the scenario is, which is a little different from standard PAO operations. In standard PAO operations, the pilot and the response team are separate. You have a helicopter pilot who's in the front who just knows coordinates of where they're going. And then you have the response team in the back who are working on what is the actual emergency that we're responding to. So with a single-seater aircraft, like the Helix aircraft, we have to bundle that in one. So how do we make sure that the pilot is able to pilot the aircraft during the flight, and then the first responder is able to be prepared to first response after the flight? And a lot of that comes down to flight planning and then also the training and mission preparedness so that that person can be thinking about flying while they're flying and then thinking about the response as soon as they land. Making the aircraft as intuitive as possible to fly and giving them the information they need on the flight deck is some of the core projects that we're doing right now. When mission planning, we have a map that is able to plot coordinates and take in some of the meteorological data to show how far your range ring is. So that red ring that's decreasing over time here, that's showing how far, if you were to continue your flight, you'd be able to go. So you see here, this is a flight from Sausalito to the Golden Gate Bridge and then back in. And that's really critical because we want to be taking in the environment as well as the aircraft performance to make that one single action to be able to say, this is where the call came in from, this is where we are, what's our route to get there, and then how are we getting back? The aircraft can be towed in a trailer, like you see right here, and then assembled in about 30 minutes. That's possible if we're going to have different dispatch stations where we don't want to fly in between them, but we want to be able to service in different environments. So we actually, typically the very first flight of the morning is to fly the aircraft upwind. Based off of the prevailing wind direction for that day, so that it has the optimal area to be able to respond to. So setting up a few different dispatch sites is really critical. So that aircraft could be driven overnight and set up there in the morning, or it could be flown upwind to that new location. Then pre-flight checks. So this is something that we're decreasing the amount of time to take pre-flight checks and also moving a lot of the pre-flight checks so that they're built in within the aircraft. So the aircraft needs to know who the pilot is. And once you put in the pilot, it'll add the pilot weight. That pilot has to do an I'm safe checklist, which they can do at the beginning of their shift to be able to say that they are ready for flight, they're trained, they're qualified, and the environment is conducive to flying that day. They go into the wind forecast, the weather forecast, and the environmental conditions, and then they do the aircraft walk around. So ideally, throughout the day, every 30 minutes or every hour, we'll go through the aircraft to ensure that it's flight ready so that anything that could prevent it from flying is addressed prior to the dispatch call. Things like checking the joysticks, checking the elevons, checking the propulsion systems, making sure the airspeed sensors are working and that the aircraft has an optimal level of battery for its flight. And all of this can be done from an app. So you don't have to be getting in and out of the cockpit or kind of interfacing with the aircraft. It's just all done through an app where you can check these systems and interface with the aircraft. As you can see, it's thorough and goes through so the aircraft will do a built-in check on its propulsion systems as well. This visual inspection check is done at the beginning of each day just to ensure that the aircraft is ready to fly that day, and then after every flight. It is possible to have small rocks. There's these rocks that are between the size of a pebble and a golf ball that are just the right size that on landing they can get just into the rear of the propeller and cause a little nick. So it is important after every flight to check the propeller quality. And that's a very simple owner level maintenance that can be done to swap propellers. Then the actual flight. So on the top, you have the flight deck that the pilot would be able to see during the flight, which shows the state of health of the different systems on the left-hand side, their amount of battery capacity remaining, their motor temperatures across all 8 propulsion systems, as well as the peak motor temperature, which they want to keep in mind. Then you have the ground speed and the pitch of the aircraft. So those two are correlated, and depending on what tailwind you have or headwind, your peak speed would be a little bit different. The aircraft map is showing you how you're tracking in terms of coordinates and direction and distance. So that's very helpful. Typically, people look at the map for 2 reasons. One is just to double check where they are. So when you're up in the air, making sure like, okay, is it this house or that house? You can see the actual landing location on the map. You can have that positioned out. So you can have that coordinate spec that's showing you where you're trying to get to. And the second is to see how well you're tracking a line. So let's say you wanted to go straight down a certain heading. You can look at the map and see, okay, how tight am I tracking this heading, or how well am I doing this perfect figure 8? So visually, that's very helpful. And then on the right-hand side, you have the altitude. So both your mean sea level altitude, your distance above home altitude, and your AGL altitude. And then at the very bottom, you can see it says whether it's reported through radar or through GPS. So when you're close to the ground, it'll switch over to radar, and it'll be detected from the onboard radar systems. And then when you're higher up in the air, it'll be doing it through GPS. And the two are working together. From the bottom picture, you can see what the view looks like. So this was a flight that we flew by the Golden Gate Bridge in San Francisco. It was absolutely beautiful with the fog coming up over the hills, a little bit of wind by the Golden Gate Bridge. If anybody knows that area, it's famous for sailing, kite surfing, and wind sports. But the aircraft has no problem. It's able to rotate into the wind, track its position, and be able to safely operate and be able to get to its destination. Then after flight, so after flight and after the emergency response mission, it's really critical to be able to have all that flight data available to not only the pilot themselves, but also the aviation director within the PAO. That would show things like if there were any alerts on the aircraft over the course of the flight that would want to cause either preventative maintenance or additional training for the pilot. It shows the flight duration, which is tracked at a pilot level, so you can monitor your stats to see how well you're doing as a pilot and how current you are. Also, your airspeed profile, your battery capacity, what your propulsion system's peak temperatures were. So this is a very good tool for both using to track a fleet of aircraft, as well as see how you're performing over time, how efficiently you're flying, and how far you're able to fly in a single mission. So this is all app-based, but it's also available in a web version. And some of this data can be extracted and kept for public safety records. Then finally, post-flight, not only is there that onboard app data that's shown on the aircraft and shown to the pilots, but we also have a huge amount of data that is uploaded to the cloud and available at a fleet-wide across all vehicles. So not just the vehicles within that specific PAO. This is used at a very in-depth level from engineering, where we can go in and see how are these aircraft performing against the entire fleet of aircraft? Are they being operated the same way? Is there any degradation over time that would cause us to either change software, change hardware, or do preventative maintenance? And how is this vehicle performing relative to that entire population of other vehicles? So this data bank is something that's extremely valuable. Pivotal has been very key in ensuring that our data for all of our flights since 2014 is saved in the same place. So we're able to look back and see between the different version of aircraft, how has the aircraft performance changed? Between the specific version of aircraft, how has the performance changed? And then we're also moving forward where over time, as maintenance and upgrades are put in place, how do they affect that aircraft and the whole fleet? Then I have this great video of some of the progress that we've made more recently. So that brings me to the end of my prepared slides for introducing what will hopefully be a good discussion and questions about what Pivotal is doing, the mission and history of company, and then what we've started to do with Hyde County in the response area. So thank you so much for listening. I hope that it was informative and gave you really good background on what we're doing, where we are, and where we're trying to get to. And right here, you've got a picture of just some of those pilots. So we've got pilots from all around the US and actually all around the world who've come in and learned to fly. We have two primary training sites, but we are able to actually move the aircraft and sim to other locations to be able to open up new training sites, which we're excited about. And we are actively training someone right here today. So by the end of the day today, I expect him to be qualified and starting his journey as a pivotal pilot. So I'd love to answer any Q&A that might come in either through live questions or through the chat, if there are any.
Hey, Kristina, this is just great. We love it. I'm sure everybody loved it. You cover a lot of ground. It's very interesting and really appreciate it. Uh, I'm going to take a fair advantage. I'm going to get to ask the first question. From a 103 qualified platform to qualify as a public airplane operated by the county, how difficult was it?
So
Do you have to do it every place we go? I mean, for example, a different county. I'm hoping they can copy the same cookbook. So once we started, it should go easier. But anyway, I'll let you answer the question.
So exactly, you hit it on the knot. So how challenging is it to set up the very first PAO for an eVTOL? I would say it's quite challenging. The people from the FAA have never done this before. The county has never done this before, and Pivotal has never done this before. So all of us are reading and interpreting the regulations saying, well, we believe based off of precedents and what we understand of the aircraft configuration and what we understand of the current public customer that this is the proposal. Then the FAA comes back and say, okay, we're reading that proposal, we have these questions. So it's a back and forth so that we have mutual consensus. Now, that's been the framework of what our progress and work in 2026 has been. Now, with Hyde County, we've been able to set up a PAO for them. So many counties have a PAO already, a public aircraft operations. If they're operating helicopters or drones, they'll have a PAO. And if they have a PAO, then they'll have a director of aviation or an aviation director within that PAO who's accountable and responsible for the operation of the vehicles. So we didn't have that in Hyde County. So we had to set that up so that Hyde County had the skills and experience. And we're not just going to go and take the chief and say, hey, you're now responsible for all these aircraft. That would be unfair to the chief and irresponsible. So we needed to find someone who was able to work for Hyde County and be part of that public organization, but also have the knowledge and experience of what a PAO is and enough knowledge and experience about the Helix and BlackFly aircraft and architecture to be able to have that operational authority. So that was a hard thing to put in place for the very first time. And I think that Pivotal did it in a very novel and creative way, focusing on customer while also listening to the FAA. And then the community was also a challenge as well, because many people in the community really wanted this. If it's going to bring response faster, we want it. Being the very first as well in North Carolina, that was something that was very positive. But there was also other people in the community, the crop dusters or people who are private pilots flying, who are concerned. This is new. This is novel. Am I going to be safe in the sky? How do I know I'll be safe in the sky? Because ADS-B is not required in these types of rural areas. And, they are already quite nervous as private pilots, as I am when I fly, of things like drones. Someone who's not skilled in what I'm flying is only skilled in what they're flying that could become a hazard to me. So we had to really meet with the community and talk with the community to ensure that we had appropriate deconfliction. And then what we're doing next is we're turning this into a framework so that any public organization that has a PAO or doesn't have a PAO can be guided by Pivotal to set one up and to be able to operate the aircraft. Actually, registering the aircraft is quite easy. They just need to be registered as a Part 91 and accepted by the aviation director and included on the declaration of PAO to the FAA.
Okay. Good to know. It's what you guys went through is not only, I think it's obviously important to Pivotal. I think it's important for the whole industry, on many applications, public service related applications. So I really appreciate you guys taking a lead on that.
Yeah, and we're
Yeah.
writing a white paper on what does it look like to integrate drones? Where are drones going to be
Mhm.
most useful?
Yeah.
Where is a single-seater eVTOL like Helix going to be most useful? And
Okay.
where is a helicopter most useful? Because we're not replacing the missions that a helicopter must be deployed on. But we might take away a mission where all you're trying to get is one bag to someone or one responder to someone, and you're waiting for a helicopter,
Yeah.
you're paying for a helicopter, and you're having a whole helicopter go. Why not have that paramedic be able to be dispatched faster? So we're augmenting what is available to a public organization in terms of their aircraft operations.
Make a lot of sense. Thank you. We have Danielle raise her hand.
Hi, it's not so much a question, but a comment. Kristina, that was an amazing presentation. I had no idea that Pivotal was even in the emergency response space. I have some friends that have flown. I've been in the simulator. I've followed you all for a very long time, but I had no idea that you were that far along. So that's exciting. I'm very much looking forward to that white paper. So really good job. I loved it.
Well, thank you. And I think what we've done so far is incredible. We're a small team and we're really trying to make sure that we have real response. So it's not just about setting it up and being able to figure out where all the hard parts are with coordination and communication with the FAA, but it's really how do we make this so it's going to be used? So it's going to be able to help some people and which environments are it most helpful in, because in an urban environment where you've got skyscrapers, like this is not going to necessarily be the first response tool that's used. but it might be used quite effectively in some of these more rural environments where they wouldn't have to draw on a helicopter that's 3 counties away to be able to come and give response to their community.
Interesting. Will you or anybody on your team be at Oshkosh or EAS?
So EAS, I'm not 100% sure, but I know at least 2 people from our team will be at Oshkosh.
Okay, EAS was the slide that Johnny shared at the very beginning, but the weekend before Oshkosh, so it starts on Monday,
Yeah.
so that's Saturday and Sunday right before, the Vertical Flight Society is putting together the electric aircraft symposium.
Hey,
Yeah, I
So
know.
I'll be
Danielle, I'll be
yeah.
there.
Yeah.
Oh, okay, very cool. Okay, well, I look forward to meeting you in person. I don't think I've met some of your team, but I don't think I've met either one of you. So anyway, good job. I'm looking forward to seeing more. Will your aircraft be there as well?
No, we're not bringing an aircraft this year. We have brought it. That's where we did our introductory flights.
Hmm.
Um, but this year it's not part of our event lineup, unfortunately.
Okay, too bad. I haven't flown in one yet, but I did go in the simulator, and that I remember there were two suns or two moons. I don't know if that rings a bell for anybody, but it's stuck in my memory. Anyway, good job. I liked it.
Actually, my screensaver is a photo I took that the one of the VTOL was taking off and flying into the sunset. That was one of the best picture I have taken, and so I'm using that as my screensaver.
All right.
Love to hear that.
Also, I have a question. I was looking at the angle when you're cruising. Looks like the way the cockpit and the windshield is arranged. You seems like we're standing a little bit or sitting a little bit more straight up compared to conventional airplane. Does that give you a great view of where you're going compared to the, say, regular traditional airplane in the cockpit? I mean, we have to stick our neck out and looking sideways to see, well into the front area. But it looks like the way it is designed, do you get a better view while you're cruising in cruise mode?
Yeah, so I'll just show you this picture because this aircraft is in cruise right here.
Hmm.
And I see what you're saying. The cockpit the cockpit itself is you're sitting pretty comfortably. So when you're in cruise mode, you're at the normal attitude of a chair. So you're not pitched forward, but the canopy itself is actually cut so you can see below the horizon when you're flying in cruise mode.
Yeah.
So when compared with a like a tailwheel aircraft, you have even better view than that. So it's much better than something like a Cessna or a tailwheel or like a low wing plane when you've got things obscuring it. It's quite good. Now, for when you're coming into land in hover mode, your visibility is quite restricted. So you're pitched back. It's more like a rocking chair. It's not like you're like full vertical or anything. It's like a rocking chair. And you have to look over your shoulders to be able to see the ground. So that's why we've employed an advanced camera solution so that you can look at that flight deck and you can see 360 of what's underneath you. So that's something that wasn't available on the BlackFly aircraft that is available on the Helix aircraft.
Nice. Looks like Carl has some raise his hand. Carl?
Yeah, awesome. So Christina, I love what you guys are doing, and Ken, thank you for going in this direction. As you guys know, I'm a huge fan of this use case. I've got a ton of questions, and I don't want to dominate all your time, but let me throw out like the most significant one is you guys have started to deploy here. Is what was the biggest surprise that you had when you started working with first response organizations, particularly in Hyde County here? What was the biggest thing that you were like, oh, I wasn't expecting we were going to have to do this or that sort of thing? What was the, if anything, what jumped out at you, or what was something that kind of caught you off guard?
Well, one of the things we knew would be an unknown to us and that we were going to have to design was really what's the training for specifically an EMS responder? Because we know how to train a regular person how to fly this vehicle for recreation very, very well. You can fly it, you can mission plan, you're having a great time up there. But in typical PAO response, as I mentioned, the pilot and the response team are separate. So how do you manage that workload on one person when they are both the PIC and the pilot and the responder? Typically, in those scenarios, they don't tell the pilot it's a child, because if they do, they want to make sure that pilot is going to stay within the operational control of that aircraft and aren't going to push any limits based off of the additional pressure that it's a child. So one of the things that we weren't sure about is how do we develop that training program? So what we did is we basically had a trainer full time after everyone came, all the EMS responders came, got fully qualified through our standard training program, and then we sent a trainer with them. So every day a trainer's with them, every day a trainer is talking to them, and that trainer is also an EMS paramedic. So before they became a BlackFly pilot, they were an EMS paramedic. So they understand the loads of a paramedic, and they also understand what it's like to be a very experienced BlackFly or Helix pilot. And that's something that we're still developing because, we want to make sure that every mission is successful and every mission is within the operational control and all the flight limitations of that PAO. So that's one of the biggest kind of unknowns is how do we deal with the human factors and really equip them with the right amount of information? Do we actually hold back that response information until they land and then give them that? Or is the workload as a pilot sufficiently low that they can be thinking about both? So that's the first thing that comes to mind. Figuring out the landing zones, and obviously near houses, there's a lot of wires. So what's our wire management system? Even if we do, thousands of landings, you don't want to miss a wire one time, but you also want to get close to that house. So that's another obstacle that's quite challenging.
Yeah. Awesome. Thank you so much. This is great stuff. Really encourage you guys to keep going in this direction. I see Al's come off. Al, you want to jump in? I've got more questions, but we should let other.
I got to share. Can I go, Johnny?
Please. You guys can take turns.
So, Kristina, glad to see you talking. I've been chair of the eVTOL Flight Test Council for about 6 years now, and you guys are always welcome to join in and hear the conversations. One of the conversations we've been having for quite a while has to do with the aircraft capability, well, largely having to do with the energy available for the performance. And I saw your displays that look pretty simple. How are you able to assure that in the face of headwinds or turbulence and so forth, that the aircraft still has enough energy to get back on the ground safely? Do you have a very conservative battery time or some sort of a countdown that accounts for winds and sophisticated calculations? How do you do that?
That's a great question. So there's a couple ways that we do that. The first is that we don't want to overcomplicate it. The aircraft is only flying at between 200 feet and 400 feet above the ground. So the time for it to get from that cruising altitude down to land is quite short, especially if you've mapped emergency landing zones in your environment. So if you start running out of fuel more quickly than you expect, you have a minimum fuel that's, hey, this is the fuel at which you should start an approach. This is a fuel level at which you should start thinking about your approach, or, that you don't have the ability to turn around anymore. So just keeping it pretty simple from that perspective, training the pilots on what those go, no-go battery percentages are. And then having a very accurate battery model is also really important. So the aircraft has quite a few checks. It does checks when it charges, it does checks when it discharges during flight to make sure that the battery is not making an assumed battery capacity based off of like a brand new battery or something, but it's based off of the actual capacity that is left in the actual vehicle.
Okay.
So I didn't mention so about wind. So wind, you can see what your ground speed looks like. And so what I showed in terms of that range ring, so it's taking in just like the simplified wind that it's reading right now, because we do find the meteorological wind is often at different altitudes that are very different from what the aircraft would actually experience. And that's where that range wing will come in and out. But until we have thousands of hours on that range ring. We're really training pilots to use their discretion flight plan. We've got a tool that takes in what their pilot weight is, because your weight will dictate how much battery you use per mile, and then what the wind environment is to be able to say if you're able to get there. So it is relatively conservative, but it's important for us to make sure that it's accurate as well.
Okay. So a combination of conservatism, simplified displays, simplified operations, and training pilots to look for landing zones and all of that, and the low altitude, all that combines to make it workable. And it sounds like you've been very successful at it, so that's great.
Mm-hmm.
All right, thanks.
Well, can we, Brian raised his hand, so can we go to Brian and get back to Carl? How's that?
Appreciate it. I'll be quick. My question is actually revolving around your Class 2 and Class 3 aircraft that you noted. Is there a pathway you're looking at for FAA certification? And then my next question after that, regardless of that answer, is your EIPP submission. I'm from the state of Kansas, are looking to be added on to the multi-state collaborative that I know you're an OEM for. Is the Helix the only aircraft you're looking for EIPP monetization on, particularly with the public safety notion that you were proposing earlier? Or are the Class 2 and Class 3, particularly from a congested comms environment for logistics, part of the ConOps that you're potentially looking at trying to monetize in EIPP?
So I think I'll answer that very high level and say yes, we are part of the EIPP and we are doing a type certification on a Helix variant aircraft, but that does not disqualify the Type 2 or Type 3. So if that's something that you'd like to talk to a little bit more, we could get you on an NDA and kind of talk through what that timeline could look like.
Appreciate it. Thank you.
All right. We have time. Back to Carl.
Cool. Yeah. So you mentioned that you guys are flying at 200 to 400 foot altitude, which does that mean that under 91 you've got to avoid personal property and stuff like does the person have to route their route so that it doesn't overfly houses or stuff? I mean, I guess I was expecting that the flights would be 500 foot minimum altitude, because down in the 204 to 400 foot, you do have to contend with drones. And a follow on to that is your ADS-B on, are you ADS-B out and in? Do you see other traffic? Do the other traffic see you with ADS-B?
So today within the pilot, we don't have ADS-B on those aircraft. We do want our PAO aircraft to have ADS-B. It's a safety tool that,
Right.
Maybe we're not in an ADS-B required area, but if we can let anyone know that we're in this vicinity, we want to. So it's a safety forward approach to have ADS-B out. Then the ADS-B in is also being considered. You're completely right. The Part 91 requirements are well, we're kind of in between. Okay, we've been flying this Part 103 aircraft, and now we're flying within Part 191. So how do we make sure that we're operating the aircraft in the best way possible for the response mission, but also complying with Part 91? So we can show an equivalent level of safety to the Part 91 requirements to be able to deviate from the standard requirements, as long as it shows that equivalent level of safety and that it makes sense. So no, especially in these rural communities, we don't overfly houses directly. Like, we have the ability to kind of plan visually because they are so spread out, or we go kind of around the downtown central core. But we do have the flexibility within a PAO to consider an equivalent level of safety where maybe we actually do in the future fly right over downtown, because that's the fastest way for us to go. And we've got a safety case that says it might also mean popping up to 500 feet as we go over some of those urban areas.
Yeah, that makes sense. And then do you have remote ID on board the aircraft as well as, like, if you're going to have ADS-B out, are you going to have both ADS-B out and remote ID, like for unmanned aircraft, so drone pilots or what have you, or do you try to not clutter that space?
We actually haven't considered that. We do have
Okay.
remote ID on all of our UAS aircraft that are flying in research development, but we haven't considered putting it on the human aircraft. And I believe that is because there wasn't a way to register it to the aircraft if the aircraft was a human aircraft. If it was a
Right.
Part 91 aircraft. So we kind of
Right.
got hit with that hurdle, but that's something that we'd be willing to talk through. If it makes sense and if people are able to see us in a more easy way, I'm sure that if it has a foundation in safety, that the FAA would be able to find a way to do that. But yeah, we hit a hurdle with being able to actually certify the individual device.
Awesome. I see Ken's got his hand up, so
All right, Ken, you're up.
Hi there. Great to see you, Kristina. That was a very interesting presentation. Got two questions. I guess one with the Helix. So the Helix is in flight test. Can you tell me a little bit more about how that's progressing? Do you have a couple aircraft, a number of aircraft, and have you flown piloted? That's my
So we're not disclosing that information quite yet. I'm just so excited about the progress that we've made, and I think that, while the aircraft looks the same from the outside, even within our factory, you have them lined up, and people kind of have to ask, like, "Oh, is that a BlackFly or is that a Helix? And is this the first Helix or like the 30th one?" Because they look quite similar from the outside, but as soon as you open up that cockpit, the flight deck is new. The all the electronics and avionics are new. We're using automotive grade connectors everywhere. We've got this beautiful carbon interior. So we're very excited about the success we've had in propulsion and in batteries and in the airframe and the structure. But we're not quite disclosing how many vehicles or exactly where we are in the test program so far.
And the second one, in the public service project that you currently have, your ability to operate those aircraft is because they're a public use, they're tied to a government agency, and so they're not operating in Part 103. So does that automatically, what does that mean? Is it you're operating in Part 91, but is there a certification envelope that goes around it, or in the sense you're exempt in some way?
So we're not exempt, but to give you a bit of background, so a public aircraft operations means that we, Pivotal, are not operating the aircraft. So it has to be under the operational control of that public entity. The military is the prime example of a PAO. The military can decide what is it to get your wings. You don't have to follow the Part 61 standard pilot requirements. They've designed something that shows the equivalent level of safety. Now, you're not automatically exempt. Like, you need to show that you have training programs in place, you have operational programs in place, and that you have all the same levels of safety within the operational control. But it does mean that we're no longer restricted by the Part 103 requirements. So the aircraft could be heavier, it could fly farther, it could fly higher. Now, we haven't put in place the research and development to, spearhead what the optimization of the PAO aircraft would be, because we believe we can have quite a bit of success with the Helix aircraft, and we have quite a small team. But that's a great question. So it doesn't mean an exemption or a waiver off the bat, but it does mean that we can build in what makes sense, and show an equivalent level of safety to the Part 91 requirements. And Ken just put in the chat, but I just did want to say that Helix has been in testing development since September of 2025.
And one last thing was, how about bird strike? What do you do in terms of provisions for bird strike or bird avoidance, or at that altitude, you're more likely to perhaps encounter birds than at a higher altitude, perhaps?
Yeah, that's a great question too. The thing I can say about that is typically birds, because we're flying so slowly, they avoid us because we're flying at or under about 60 miles an hour. They really kind of avoid us. Now, that doesn't mean that, 1 in 1,000 flights or 1 in 10,000 flights, we could have an ingestion. And so that's where we train people to be flying with their eyes, keeping an eye out for these different types of environments, like around the coast where you might see more birds, or around bodies of water, takeoffs and landings, etc. So we're not sure if the aircraft actually emits a sound, which is bird deterrent, because you would think with the thousands, like we have 50,000 miles flown so far, and we've not had any birds coming close to us. So it's possible that we already hit that frequency that is bird deterrent, but it's also a project that we're interested in researching to see how we could further mitigate.
Excellent. I look forward to hearing more from Ken at Electric Aircraft.
Great to see you, Ken.
Okay, well, I know we can keep going on the Q&A for a long time. I'm sure about that. Just Carl alone will probably be able to keep up the discussion for another half an hour. However, we're at the top of the hour, and I just want to say this is a great session. Excellent presentation, and the content and the discussion from everyone. Kristina, thank you so much to be a speaker, and we really appreciate it. So thank you everyone for participating, and we'll see you next month.
Yeah, thank you, Roy. Really appreciate it.
Thank
Cheers.
you very